Hello folks, and welcome to another edition of Rules of Exponents. You're going to need your notes, a pencil, and a calculator. Remember that Rules of Exponents was taught to you in Algebra 1. It is a huge concept in Algebra 2 from now until the end of the year, and so we need to make sure that you have these basic rules down. If you are struggling with them, you need to please come in and get some help with tutoring, because on Friday we are going to take these rules to the next level. They're not going to be nice whole numbers. They're turning into fractions. And if we struggle with the whole numbers, the fractions are going to get crazy. So please be aware of your learning and what you need help with. So let's get started. You do need to write down all the notes except for this very first slide. The very first slide says, what is an exponent? Okay, this is an exponent. This is in your notebook. You should have this already written down. The 2 is the base, the 4 is the exponent, and altogether this is a power. And it's read as 2 to the 4th power. It could also be read as 2 to the power of 4. Either way works for me. It means that we have 4 2's. 2 times 2 times 2 times 2. And if you put that in your calculator, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th would be 16. All right, so we got to work with some of these properties and rules, but how do I work with them? Okay, so if I have x to the 4th times x to the 3rd, what does that mean I do? Well, yesterday we talked about if the bases are the same, we could add them. Or we could say we have 4 x's, and then we have 3 more, and for a total of 7 x's. So this would be x to the 7th. Now, wouldn't that same rule apply if I said I had 4 2's and 3 more 2's? I would have 7 2's. So I have 2 to the 7th. So what I'm doing is I'm adding the exponents if my bases are the same. And I have a product, or I have a multiplication sign in between here. Okay, so that is the first rule that we need. Okay, one of the other rules that we need is that this says x squared to the 3rd. Well, what does that mean? It means x squared 3 times. Well, what does x squared mean? X squared means x times x, x times x, x times x. How many total x's do I have? X to the 6th. Well, whether I have an exponent, or an x as a base or a 3 as a base, does it matter how I work with the property? No, it's the same thing. So this says 3 squared cubed. So I would write 3 squared 3 times, because a power tells you how many you have. The powers tell you how many you have. So I have 3 squared 3 times. So now I have 3 squared, which means I have 2 3's. 3 squared, which means I have 2 3's. 3 squared, which means I have 2 more 3's. And how many total 3's do I have? I have 3 to the 6th. Now in your calculator, you could figure that out and give me what that value is. But to me, the idea and the rule is the most important thing. So what is the rule? What am I actually doing to the 2 and the 3? Well, what operation can I do to 2 and the 3 to get a value of 6? Oh, I am multiplying powers, or exponents, if you will. I am multiplying the exponents if I have a power to a power. So I have a power to another power. I'm going to multiply my exponents. Okay? So we talked about that yesterday. All right, next one. Here I have 2 different bases, and I have an exponent on the outside. Well, what does that mean? It means I have 3x 3 times. Or it means that the exponent on the 3 is a 1, the exponent on the x is a 1, and I have a power to a power of my multiple bases. I have 3 3's, I have 3 x's, and I can count them here, or I can use the rule. The rule says that everybody inside gets the outside power. So I multiply all exponents with different bases with the exponent on the outside. So if the exponent is a 1 here, and the exponent is a 1 here, and the exponent is a 1 here, then every single one of those bases gets the exponent of 2 multiplied by it. So 1 times 2 is 2. So it's negative 3 to the 2 power. And because it's negative, I got to put it in parentheses. 1 times 2, well, that's 2. So we have 2 x's. And this says y to the 2, because 1 times 2 is 2. Okay, so that's what that property means. Okay, we're going to go on to the next one. I've got this. I've got 5 x's on top, 2 x's on bottom. I have 5 x's on top, 2 on bottom. Remember we talked about canceling because 5 divided by 5 makes 1, 100 divided by 100 makes 1, 2,000 divided by 2,000 makes 1. Well, guess what? X divided by x also gives you a 1. So these guys cancel. These guys cancel. That leaves me with 3 x's on the top. Well, what can I do, or what operation can I do with the 5 and the 2 so that I get a 3? Oh, yep, I would subtract. So the rule is if the bases are the same, I can subtract exponents if I'm dividing. And how do I know I'm dividing? Ooh, I have a division sign. So that's how I know I'm dividing. All right, let's go on to another. So this one is kind of the same rule because I have a division sign and I have bases that are the same. So what can I do with the 3 and the 5? Well, I can subtract them. You always take the numerator minus the denominator. 3 minus 5 is negative 2. Uh-oh, negatives are a problem. We can't have negative exponents. So if I want to talk about negative exponents, we got to talk about how I can make that a positive exponent. So let's talk about negative exponents. Negative exponents say I can cross the line and change the sign. So if I look at this problem right here, x to the negative third, this is really over 1, okay? Because if it doesn't have a division sign, it is in the numerator. So if I want to get my negative exponent positive, I have to cross the division sign line and change the sign of the negative. So this would become 1 over x to the third. Okay, I got 1 over w to the negative 4. Well, it's in the denominator, so in order for it to become positive, I got to cross the division sign and change the negative sign. So this would become w to the positive 4, and we could say over 1, but that would be totally unnecessary if you didn't want to. Okay, so it's cross the division sign, or division line, I should say, and change the negative sign to a positive. So if we were to go back to the last slide I was just working with, and we had x to the negative 2, if I have x to the negative 2, that is obviously in the numerator because it doesn't have a division sign, so I know it's in the numerator. I would have to cross the division line and change the sign. So it becomes x squared on the bottom, and I'd have to put a 1 over it. Okay, so I can use the subtraction rule, but if I get negatives, I then have to use the negative rule. All right, so then I have 0 exponents. If I put 3 to the 0 in my calculator, I would get a 1. So anything to the 0 power is 1. All right, a couple more rules and then we'll be good to go, and we're going to do some examples. All right, here is a rule where I have 2 different bases, but they're being divided instead of multiplied, and they're to a power. Well, this says x over 2 cubed. That means, remember, exponents tell you how many times you have it. So I have x over 2 3 times. Well, how many x's do I have in the top? X to the third. I have 3 of them. And how many 2's do I have in the bottom? Well, I have 3 of them. Could I do it a different way? Well, I know that everybody, numerator and denominator, need to get that power of 3. So the rule is, if I know the exponents on the inside, and if they're not there, remember they're a 1, I can take a power to a power. And the power to the power rule says everybody gets the power and you multiply. So 1 times 3 would be 3, and 2 times 3 would be 3. Or excuse me, 1 times 3 would be 3. So this would be x to the third over 2 to the third. So everybody gets the outside power. So the numerator and the denominator all get the outside power. Okay, which means all powers are going to be multiplied. Or exponents. Okay, so could I do that same concept here? Well, if there isn't an exponent, we know it's a 1. If there isn't an exponent, we know there is a 1. 3 times negative 3 is 3 to the negative, or excuse me, 1 times negative 3 is negative 3. 1 times negative 3 is negative 3. Okay, I have negative exponents, which I cannot have negative exponents. Okay, no negative exponents. So you cross the line and change the sign. So I need to take the numerator, cross the line and change the sign. I need to take the denominator, cross the line and change the sign. And that is my answer. So power, power, multiply. Even if they're not the same base, multiple bases, everybody gets that outside power. All right, so now let's apply the rules. I've got a whole bunch of x's that if I took the numbers out, I would have 4 x's, 4 x's, and another x. They're all being multiplied. The rule about multiplication is that we add them together. So 4 plus 4 plus 1 is 9. I only see one y, so I'm going to bring that y to the 1 down. Now, what would I do with these numbers? Well, if I took out the exponents and the x's, it would say 3 times negative 4 times 2. Well, 3 times negative 4 is negative 12 times 2 is negative 24. That would be my answer. Okay, let's try another one. Anything to the 0 power is 1. So this problem is 1x to the 5th. I have nothing else, no other x's to put it with. So that is my final answer. 2x squared y to the 4th over 8x squared y. Well, if I didn't have the x's and the exponents, that would say 2 divided by 8. 2 divided by 8 is 1 over 4. How many x's do I have on top? How many x's do I have on bottom? I have a division sign. It says, the division sign says I can subtract these exponents. So 2 subtract 2 would be x to the 0. I can do that with my y's as well. This y has a 1. 4 minus 1 is 3. Okay, so I have 1 x to the 0, y to the 3rd over 4. X to the 0 is always 1, and 1 times 1 would be 1, y to the 3rd over 4. Okay, a couple more here. I have some negatives. I have different bases. I have a power on the outside. Oh, I have a power on the outside. A power on the outside says everybody in the inside needs the power. So the exponent on the 2 is 1. 1 times negative 3 is negative 3. Negative 2 times negative 3 is positive 6. 4 times negative 3 is negative 12. Ooh, I have some negatives. Can't have negatives. So I got to cross the line. So I'm going to draw a line so I can cross it and change the signs. Now I only do that with negatives. So 2 to the negative 3 will cross the line. I'm going to change that to 2 to the power of positive 3. X to the 6th is positive. We don't move it. And y to the negative 12, oop, it's negative. We got to cross the line and change the sign so it goes downstairs. Okay, so that would be my final answer. Okay, I have a whole bunch of things being multiplied here. So if I took out all the x's and y's, it would say 5 times 2. Well, I know that's 10. This says I have 2 x's. This says I have 3 more x's. How many total x's do I have? Well, I have 5 because I'd add them together, because if I'm multiplying and the bases are the same, I can add the exponents. So let's do the same thing with the y's. Y to the negative 8, y to the 5. If I add those together, I get y to the negative 3. Uh-oh, I have a negative exponent. Can't have a negative exponent. I got to change the sign, and I got to cross the line and change the sign. So only on things that are negative. The 10 is a positive 1 exponent. The 5 is a positive exponent. And so the only thing that's negative is the negative 3 on the y, and that's in the exponent. So I cross the line and change the sign. And that would be my answer. Okay, let's try this one. We talked about this yesterday. When I have numerator, numerator, denominator, denominator, and a multiplication sign, I can multiply straight across. So 4 times 1 is 4. X to the third times x. There's 3 x's, there's 1 more x. That means I have 4 x's. And then I bring over the y. 5 times 2 is 10. And there's only 1 y, so I'm going to bring it over. Now, I have this as one quotient, one thing together, so I can look and see what I can do based on that. Well, 4 divided by 10 is 2/5. Okay? X to the 4th, it looks like that's all I got there. There's no other x's there, so I'm going to leave it x to the 4th. I have a y on top, a y on bottom, 1 minus 1. Because there's a division sign, I can subtract. 1 minus 1 is y to the 0, and anything to the 0 power is 1. So I don't even need to incorporate that. Okay, let's try another one. I got 4x squared y cubed over 8x squared times xy squared. Well, there's a 1 under here. We can multiply across the top, across the bottom, and then maybe simplify. 4 times 1, 4, x to the third, because there's 3 x's, y to the 5th, because there's 5 x's, 8 times 1 is 8, x squared. I can only have 1 x, so what do I do when I have a division? I subtract. 3 subtract 2 is 1. 4 divided by 8 is 1/2, x, y to the 5th. All right, so hopefully you've written these down, practiced them, and you can come back and be a little bit more successful tomorrow. Have a great night.